Hello, welcome back, my good people. In this video, we're going to look at data visualization using Seaborn library in Python. If you're new to this channel, please do remember to subscribe, like, and share my videos. Welcome back. To begin, we'll first need to import NumPy as NP, Seaborn as SNS, and Matplotlib in line. So in most cases, you'll find that there's some libraries in Anaconda that need to be updated, and in which case you get some warnings, and because you don't want to see those, we need to import warning library, and using filter warnings function, we ignore showing those warnings. For this tutorial, we will use one dataset called tips that is already preloaded in Seaborn. So all we need to do is just load the file, and to load it, we use the function called load_dataset from Seaborn, and we specify the name of our dataset that we want to load. We can go ahead and take a look at the data by printing out the top 5 rows in that dataset. So here we see that the dataset has 7 variables. We have total bills, total bill paid in dollars, the amount of tip given, the gender of the person paying the bill, and whether there was a smoker in that party, and the day of the week, and the time, was it lunchtime or dinner, and also the size in that party, how many people are in the party. We can check the shape of that, tips.shape, to get the dimension of that data set. We see that we have 244 rows and 7 columns. The first visualization that we are going to look at is bar plot, and for bar plot, it represents the estimate of central tendency for a numerical variable aggregated over a categorical variable. Create a bar plot, we use bar plot function from Seaborn, and we specify which variable should go on the x-axis, and the variable that goes on the y-axis, the data set, and the palette. And in this case, the palette represents the parameter that specify the color of those bar charts. And then we can go ahead and set the value labels for the x-axis and y-axis. In our case, we want to plot on the x-axis, we want to have sex, and on the y-axis, we want to have the total bill, and the palette we use set1. And on the x-axis, we have sex on the x as the x label, and the y-axis label would be mean bill. If I execute this, we see that we get the mean bill on the y-axis, and on the x-axis we get sex. And red represents male and female is represented by blue. In some instances, the default font size is not good for you. So all you need to do is specify the font scale that you want. In this case, to do that, we use set function from Seaborn, and we specify the font scale as an argument in that set function, and we run it. And then you can go ahead and run the bar charts again. We run that code to create them. You'll see that there's a bit of a difference in the font size of everything in that chart. You can see the difference. In this chart, the mean bill is a bit smaller as compared to whatever we've created after setting the font scale. And as you can see, the bar plot is making use of the mean of the total bill paid in dollars for the two categories. It's getting the mean of those for male and female. But from the bar plot, we can't tell what the mean is. So what we do, we can compute the mean ourselves. So in this case, we use this, we first group by sex, and then we compute the mean for those groups. But in this case, if I execute this, I get the mean for the total bill, tip, and size as the average. So I'm getting a summary table for male and female for the mean for each numerical variable in the dataset. But in some instances, like in our case, we only want to see the mean for the total bill. So in this case, we can specify, after grouping by sex, we specify the column, the numerical column that we want. In our case is total bill, and then we get the mean over the two categories of sex. So in this case, once I execute, I see that the mean for male is 20.7 and 18.1 for female, and these have been represented in the chart that we created. And this is a bit, the reasons why we use visualization is to represent the data. So it's easier to use visualization, it looks better, but there's an issue. In some instances, using mean for central tendency is a bit misleading because it might be affected by the outliers, either extreme values, too high values, or too low values. In this case, we can use the median as the measure of central tendency, and to plot it, we use the same code with two differences. We introduce an argument for estimator, whereby we calculate the median using NumPy, and we choose a different type of palette or the color choice. So in this case, we use the palette as HLS, and we leave everything else to be the same, whereby the x-axis will be sex, y-axis is total bill, but the aggregation will happen on the total bill will be median. So, and we change the y label to be median bill. So executing this is what I get. So we get on the y-axis, we have the median bill, and on the x-axis, we have sex. Remember, earlier on, we had set the font size to be 1.35, and that will remain for as long as we haven't changed anything. So as you can see, we see that the median bill is about 18, and for female, we see that it's about 16, and it's hard to tell from the visualization, but we can actually go ahead and compute the median for each group. So to compute the median of each variable by gender, this is what we do. We group by sex, and then we compute median. So executing this is what we get. We get for any categorical data or variable in our dataset tip, we can compute the median for each. But in our case, we are not really interested in getting for all numerical variables, but rather we only want for median for the total bill only. So we have to specify the total bill, and we get the median. So executing this, we see that the median for male is 18.35, and for female it's 16.4. And according to the bar plot using the median, we see that it's whatever we got here is accurate, because now we have the actual values. We have the actual median for the two groups, 18.35 and 16.4. And that's it for the bar plot. Until this point, we've been using palettes for the two visualizations that we've created. And you might be asking yourself, how do we choose these colors? There are two kinds of colors that you can choose from when you're using Seaborn. The first set of colors, we can call them default colors or default theme that are basically inbuilt in Seaborn, but that's not to say that you can't define your own colors. You can choose a wide range of colors. We normally call them named colors that you can choose from. You can mix and match the colors that you want to use. But the default theme, these are specific color ranges that have already been selected for you, and all you need to do is just specify the various colors that you can use, the default colors, and you can actually type in this URL and click on it to see the colors that exist. Well, these are the colors that you can actually choose from. There are different colors that have been selected for you, and you can come here and choose the colors that you might want to use for any of your visualization. You can learn more from this URL. I'm not gonna go deep into that. You see, like here we have set 2. These are the colors. Paired, you can use those colors. Sequential color palettes, perceptually uniform palettes. Well, these are the colors that you can choose from depending on what you want. These are the default theme, and all you need to do is just come and get the name for the palette that you want to use. Anyway, for these default colors, there are quite a few, and you can even visualize them this way. So we have like several variations of the default theme. We can have deep, muted, pastel, bright, dark, colorblind, and so many other. So if I want to visualize colorblind and see the range of colors that are there to be used, I can execute that and we see that we have those colors. We can print some more. For example, we can say muted and execute again. Also, we can have another color range or theme. We can take, for example, bright and visualize it. So you see this is a bit bright. If you are fond of those bright colors, so you should go for the bright theme. And now, as I said, there are default themes, and also you can choose your own colors that you want. And to choose your own colors, we normally use what we call named colors. The named colors, you can actually follow this link and see the colors that are available for you to use. So these are the colors that are available for you, and we have 954 most common RGB monitor colors as defined by several thousand participants in the XKCD color name survey. So as you can see here, we have, like, for the color purple, there's this code that can be used to specify that color, or you can actually decide to use the name purple instead. But it's always important to maybe bookmark this website, or just bookmark this website so that you can come back to this and pick the color that you want. So for the named colors, you can actually create your own palette that you want. As you see here, for example, for the bright, we see that we have several colors that your visualization, if this kind of theme is selected, then the visualization will pick colors from this. So what you do, so you can create your own palettes with some selected colors of your choice. You can say colors equal, then you pass a list of those named colors that you have that you've actually selected from this website. You can say pig green, khaki, blue green, whichever you want to choose, and make your own color palettes. So after you create this and you assign it the variable colors, and then you print it out this way using that function. If I execute, I see that I've actually selected how many colors: sky blue, cerise, color gold, seafoam, purplish. So those are the colors that I've chosen. So if for any visualization you specify that list, that's exactly what is going to be used for your visualizations. So you can select the colors that you want, either using the name or the code. For example, you can create from YLG and scheme. So these are scheme, a naming scheme for the colors. Rather than using the actual names for those colors, you can use this scheme of naming, and then we assign it to pretty colors. So once you save it, you can call it in the subsequent visualizations that you might want to create. So if I execute that, so we have a color scheme or the palette called pretty colors. Remember that. The next visualization that we're going to look at is what we call the count plot. For the count plot is almost the same as bar plot, except for this one, we're only counting the number in each category. For example, we can go ahead and create a visualization for the count plot using the count plot function from Seaborn. And in this case, you only specify what you want in your x-axis, and Seaborn will count the number in each category. So you specify what you want in your x-axis, the categorical variable you want, and we specify our data set. And for the palette, we choose the pretty colors that we specified above here. So if I execute this, I get male and female, Well, these colors don't look so good. So perhaps we can use the default theme that we have. And it's very important that because you are making many visualizations, it's always important to save the color theme that you want. So what you can do, you can actually save a color theme that you might want to use for all your visualizations. For example, you can say the current palette, you assign it default theme bright. So I execute that, and now I can create my count plot. And instead of using the pretty colors, we use the current palette. So if I execute this, I now get, well, a better looking count plot whereby we have two bars, male and female, and we see that it's showing the count on the y-axis. And that's, as the name suggests, it's called a count plot. So we expect it to count a certain number of occurrences for each category in a categorical variable called set. Well, sometimes you might not like the style that you have. For example, here, as you can see, we have a dark grid kind of style. You might decide to have a different kind of styles for your visualizations. And here you can set it to be white grid, dark, or dark grid, like what we have now currently. So if I decide, for example, to have it as a white, you can use that and comment this out. If I execute this, you see I have a white background behind these bars. We can play with this. You can say this is actually a dark style. If we execute that, we see just a dark background, and sometimes you can have even the white grid, or you just want to have white background, but with some horizontal lines. So I execute this, I get that, which I think this looks better because it kind of gives someone a feel of what the count is. Like here, I see it's 150 and it's just above 150. So we can say probably 160. Yeah, something like that. For male, and for female, it's about probably around 80 something. So that's how you can do a count plot. The next set of visualization you're going to look at is the box plots and violin plots. Box plot and violin plots show the distribution of quantitative variables by category by plotting the median, the lower and upper quartiles, Q1 and Q3, the interquartile range, IQR, whisker, and outliers if they do exist. We'll begin with box plots. Create a box plot visualization. We use box plot function from Seaborn. We specify X to take values from the day column, Y to take the values from the total bill column. Our data is tips, and the palette we are going to use here is HLS, and we take 4 colors. So if I execute this is what I get. So basically on the x-axis we get day, and on the y-axis we have total bill, and we have 4 colors that have been used, and we see for each day we have some set of outliers, which was a bit low for Monday and Tuesday as compared to Saturday and Sunday. And we see that the median, which is the line at the center presenting the median for Thursday, was a bit higher than Friday, but it was highest on Sunday. In some cases, you might want to have the box plots being horizontal rather than the vertical. So here we introduce another argument in the function box plot, which is the orient equal h. By default, it's always vertical, but if you want to have a different orientation, then you have to introduce this part where you say orient equal h. If you execute this, we now get our box plots being horizontal. We see that on the y-axis we have day, and on the x-axis we now have total bill. What if we wanted to introduce another categorical variable such that we have for each category in the third variable that we're introducing to be represented by a separate box plot? Here we do the same thing, but we just set the style to be white, here we do the same thing. We use the box plot function. We specify the x-axis variable and the variable that goes to y-axis, which is the total bill. And now this is what makes the difference. We introduce a third variable where the value for total bill will be classified into two. We know that the smoker has only two categories, which is yes or no, and the rest remains the same. So after executing this, here we see that we have for each day the total bill or the box plots have been generated to be two, each one separate, representing either whether there was a smoker in the party or not. So for smoker is red and no is green. And that's basically how you're able to create box plot visualization. The next visualization you're going to look at is violin plots. Plot these violin plots is simply the same way you're doing for box plot, but with the function violin plot. And something else that you're supposed to note is that all the plots that you create will take whatever grid type you had specified earlier. So when I execute this, I get these images that look like violins, and on the y-axis we have total bill, and on the x-axis we have days. They kind of look nice. I love the colors, but you can change the color to match whatever you want. But in this case we use set 2. Probably you might see that the grid is not good. You see we have a white grid. So if you want to change the grid, we do the same thing. We set the style to a different kind of style. We can say dark grid. So if I execute this, we get now a dark grid. So it helps the visualization to look nicer, but it kind of look too dark. So probably we can change the colors, and we can change the color palettes, and also change the grid or the style that we want there. And probably we can actually even introduce that variable at the same time. So first we set the style. After setting the style to white grid, meaning that it's gonna be a white background with some horizontal lines, and we introduce that variable where we want the total bills for each day be categorized into two, and we change the palette to be muted. Muted is one of the default theme that comes with Seaborn. So if I execute this, we see that now we have two different categories for each day. For each day we have male and female. Male is represented by blue, and I believe this is orange. Is it orange or brown? Whichever color that is. But just know that blue represents male. So, but what if we don't want to have separate violin plots for male and female? What if we just want to have one violin plot, but the violin plot is divided into at the center vertically wise, and one side represents male and the other one represents female? So in that case, we introduce another argument, and this argument called the split equal to. It means that rather than having two separate violin plots for male and female, we can split one violin plot into two, and we change our color to color blind. We execute this is what you get. We see that one side has the color blue representing male, and the other side represents female for the 4 days that we have. And we can also use a map function to plot whichever chart we want or visualization. In this case, the first thing we do, we can actually do a distribution of total bill amounts by time, sex, and smoker status. And to do that, we can actually use this line code to achieve that. So first, you'll set the style to text. The palette is set to, and the font scale is 1.1. And then we set the facet grid such that we have our data is tips. Then we have all is time, the time variable. Then we have size to be 5 and aspect to be 0.75. Then we can use the map function come up with the visualization that we want. So here the map function will take the chart type we want, and then The second argument is sex, meaning that it's we have variable sex, total bill, and smoker. And then the palette, we pass a dictionary with no take B and yes take Y. These are the colors that smoker will be split into, or will be the colors that will be used to represent yes or no. So, and then we set inner to be none, meaning that we won't have this a bar with a dot at the center. And then the line width, there will be a line in between. Maybe I can just execute this and I'll show you what it means. So we have a line at the center. One side represents lunch, time equal lunch, and on the right side we have time equal dinner. So meaning that there's a split. There's a split, and we set the width to be 0.75, and this time you say left equal true. And then now we can set where we want your legend to be. Legend is just the smoker is yes, no. That is the legend. You specify where you want it to be. And in this case, you're saying for the legend for smoker should be on the upper left corner. You can change this to maybe upper right. You can actually play with this. So you see that it's upper right on one side. So basically, but I like it left aligned. So you can say upper left. So this looks a bit better. So you see, this is comparing the distribution when, depending on the time of the day. And on the x-axis we have sex, and on the y-axis we have the total bill. And for each violin plot, it's showing one side for smokers and the other side for non-smokers. And then we are comparing the time of the day. So basically we have a pair of violin plots for each time of the day. Then the next kind of visualization we are going to look at is what we call a strip plot. And basically a strip plot plots qualitative, categorical variable, and a quantitative variable. And this should not be confused with scatter plot, as a scatter plot plots two quantitative variables. And to do that, we can first set the style and the font. So we say that the font scale is 1.35, and we set the style to be white grid. And then we can use a strip plot that has on the x-axis we have day, and on the y-axis we have total bill. Our data as usual is tips, and the palette we use has 1. So if I execute this, I'll have a strip plot. Each strip are showing different days from Thursday to Sunday. Then, but in some instances you might find like there are some overlapping points such that you won't actually see all the points. So for you to have a clear picture of what we have, we can introduce noise to each point so that we have separate points. We use something we call jitter. We set it as true in the strip plot function. So you see we set this as true and everything else remains the same. So when I execute this, if you can see here, right about here, we had these 2 points which seem to almost overlapping, and we can actually separate them by introducing a little bit of noise by saying jitter equal true. Now, suppose you wanted to color code by a categorical variable. Suppose we say we want to color code by, so here what we do, you can use hue. I know by now you are familiar with what hue means. This is just the third variable that you want to color code the strip plots or the points. If I execute this, we see now we've introduced different colors for the two categories of sex or gender. So here we see we have total bills on the y-axis, day on the x-axis, and the strip is in two separate colors. Suppose now you didn't want to have the legend, and legend, this is the legend. If you didn't want to have the legend, you can simply introduce, after plotting the strip plot, we can use legend underscore dot remove function to remove the legend. And we can actually do this, execute this. We see now we don't have legend that was on the top left corner. And if you had some overlapping values or overlapping total bills, it's always important to introduce the argument jitter equal to true, just to have a clear separate points for anything that was overlapping. So you can do that, but it's always important to have the legend, because you need to tell anyone viewing your chart or visualization that the color code means something. So I'm gonna execute this, and this is what we have. It's the same, almost the same chart, but some noise has been introduced, and you can see all the points in the strip plots clearly. Now, suppose you wanted to combine two or more plots into one. For example, you might want to have a strip plot and a violin plot. So how would you do that? In this case, all you need to do is just plot a violin plot and a strip plot in the same cell. Remember, you're using Jupyter Notebook, so that's exactly what you do. Just combine both in one cell. Now, when you execute this, we see we get a strip plot and violin plot for the days that are in our data set, Thursday, Friday, Saturday. And then on the x-axis, we have tip. In Seaborn, there's a very important function called FactorPlot. A FactorPlot will enable you to pass the type of visualization you want to plot alongside all the other arguments, and this is how you can use it. It's called FactorPlot. You can have it as a header, and to use it, we can first set the style, set the font scale, and choose your colors that you want, and save them as a variable. And then you can pass this the x-axis, the variable, the x-axis inside the FactorPlot. We can pass the total bill as the y-axis, and our data is tips. And then here is the most important. We say kind. We want a strip, and our palette is my color. We execute this, so I get this. X-axis we have sex, and on the y-axis we have total, and we have two different colors. This color is for a code for green, and this is code for yellow. We can actually play with this. We can say this one to be, maybe let's say bar. Let's see what happens. So if you change this, the kind, to bar, probably you can even decide you want a violin. Let's see what happens. You get a violin. So here is where you just change the kind. You can plot as many, you can plot different kind of charts that you want, or visualization. But in our case, we had strip. So executing that, go back to our strip. Thank you for watching. Please do remember to subscribe, and let me know if you have any question in the comment section.